Dear viewers, today I am going to explain you a little demo of atomic structure. What is atomic structure? Before understanding atomic structure, we must know what is atom. The history goes back to Democritus, who for the first time imagined that every matter is made up of very small tiny particle called atom. This atom was further explained by John Dalton. John Dalton was the almost first scientist who gave postulates about atomic theory. He said that every matter is made up of a small tiny particle called atom, and atom is indestructible, indivisible. In Greek, the meaning of atom is also indivisible, which cannot be broken, which was later on proved wrong. But Dalton's it was very important and first attempt by John Dalton to explain about atom. In his postulates, he said that number one, atom is indivisible, indestructible. Every matter is made up of atom, and atom takes part in chemical reaction. And atom can neither be created nor be destroyed. And a similar atom, every substance like gold, copper, it has similar atoms. Similar means in terms of mass, in terms of nature, chemical nature. But different substances have different natures of atoms. But there was a drawback of John Dalton, that he could not explain that atomic structure. Later on, your J.J. Thomson came forward. He did experiment on cathode ray tube and gave a J.J. Thomson model of an atom. He said that an atom is spherical in shape, and it is like a Christmas pudding, plum pudding model he gave, and it's also known as sometimes watermelon model. In this case, he assumed that the whole spherical shape of the atom is positively charged, evenly distributed positive charge, and somewhere electron, the negative charge particle, is embedded upon it. Later on, it was proved wrong by Rutherford. Rutherford came forward and did an alpha particle experiment. He bombarded doubly charged helium atom on very thin gold foil. It's so much thin that almost 1000 atoms were in the thickness of the gold foil. When he bombarded the alpha particle, doubly charged helium atom, he found that most of the alpha particles went straight forward, and very few returned back, and almost 1 out of 20,000 alpha particles came back on the same path. Upon this observation, he concluded that an atom has a tiny nucleus, a very small nucleus as compared to the size of the atom, and in the inside nucleus there is a positively charged particle. And around the nucleus, electron is moving around in a circular path with a high speed. But he could not explain the stability of that. Then came Niels Bohr. Bohr said that every atom has orbit of fixed energy level. So whatever electron is moving in any particular orbit, its energy is equal to the energy of that particular orbit. The orbit which is closer to the nucleus is the orbit number 1, and it has lowest energy. And an orbit which is away from the nucleus has more energy, and it is counted from the orbit that is nucleus closer to the nucleus. For example, if this is nucleus, then this is the first orbit, n is equal to 1, and this is the second orbit, n is equal to 2, and this is the third orbit, n is equal to 3. So in this way, orbits are counted. First orbit is known as capital K, capital L, and capital M. This way we represent the orbits, different orbits.